Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be looking at 10.1, which is getting into probability. Unit 10 is all about probability, and some of it, very small portion of it's going to be maybe a little bit of review, but the rest of it should be new material. So just keep that in mind as you are taking your notes, as you're doing your assignments, that again, a lot of this is going to be new material. So with that, we'll go ahead and get started. In Unit 10, 10.1, we're looking at probability and what's known as set theory. So sets are, as the name might imply, sets of numbers or groups of numbers. And there are different ways that these can be represented. Sometimes they can be represented graphically or in something like a Venn diagram. And then other times they can be just listed as sets of numbers. So we see these in all different kinds of ways. If we were doing this in person, or if you're doing this, on the supplemental resources, sometimes these are represented by, like I said, Venn diagrams, where you could have different groups that are represented by the Venn diagram. Remember, a Venn diagram typically is looking at, well, not always, but typically it's looking at a group of circles. They could be overlapping. It's possible that they're not overlapping, and it can be more than two. But if I am to say, look at an example where I have, in this case, two different circles, all the numbers that are in one group I'm going to call set A, and all the numbers that are in the other group I'm going to call set B. Now, in this example, there are a couple areas here. There's an area where A and B overlap. There are areas where A is by itself. There are areas where B is by itself. And then there are areas that are covered by neither A nor B. And so we have names for all of these sections that are represented. Okay? In an area that is covered by two sets, let's say A and B, we refer to this as an intersection. And notationally we will say A intersection B. So this symbol is an intersection symbol. You'll need to use your special characters if you're trying to type this. But it kind of looks like an upside down U. If you're just trying to type it in basic text, some students will use like a lowercase n to try to represent that. And as long as I know what you're talking about, you're okay. I'm not as concerned with the equation editor or you using the actual intersection symbol. But that's what is represented there. So A intersection B is saying the elements that are in both A and B. Now, as I mentioned, you can represent this graphically, but let's say we're going to define each of these, and rather than using the diagram, I'm going to list out some numbers here. So let's say my set A is 1, 2, 3, 4, 5, and 6. And I'm going to say set B is a set of numbers. We'll call it 2, 4, 6, 8, and 10, for instance. Okay. So if I asked you for A intersection B, that is representing the elements that are both in A and B. Now, a couple of things, because this is probably the first time you're seeing set theory. When we write out a set of numbers, we are using the curved brackets. These are above your square brackets on your keyboard. So if I wanted to write A intersection B, or the elements that are in A and B, then I'd be looking for what numbers are in both A and B. And those numbers in this case would be 2, 4, and 6. So A intersection B, my answer here would be 2, 4, and 6. Okay? So that is an intersection. You're looking for the elements that are in both of those sets. Okay? So that is one example. And in your assignment, you're going to be asked to define an intersection and then also sketch a Venn diagram showing that. Again, it can be in your own words, or if you want to use a textbook definition, you can. But that's how you would find A intersection B. We also have something that's known as a union. So a union is going to be represented by, looks like a U. And again, you can use the U on your keyboard if you don't want to pull out the equation editor. But union is just like intersection is representative of and, union is representative of or. So a union is looking for elements that are in either the set A or the set B. So it can be in one or the other. It doesn't have to be in both. Now, looking at, let's say, the same example, I had a few elements that were duplicates, right? There were 2 2s and 2 4s and 2 6s. When you're writing a union, you don't need to write the element more than once. So even though 2 is in both A and B, I don't need to write it twice. Typically, with set notation, you want to go in order. So let's say I have 1, 2, 3, 4, 5, 6. 2, 4, 6 are already covered in my B set, and then I also have 8 and 10. So those are all the elements that are in either A or B. Those are going to be the main problems in 10.1. You're also going to have a couple questions that are involving something other than just a set pair of numbers. So for instance, you might be asked a couple questions involving a deck of cards. Now we've talked about this before, but remember with a deck of cards, you have a total of 52. You have 4 suits, which are your red suits, heart and diamonds. And then you have your black suits, which are clubs and spades. So with these 4, you then have 13 values. You have 2 through 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have your face cards, which are Jack, Queen, King, and Ace. There are 13 values. There are 4 suits. That makes a total of 52 cards. If you don't know that, you may want to add that to your notes because that'll come up quite a bit in your probability and statistics sections. Okay, so for instance, I could ask you questions involving union and intersection. I might ask you, what's the probability of drawing, let's say, a 3 or a 4? Okay. Now, remember, your base probability formula is the number of events that you are looking at divided by the number of possible events. You could also solve this using a sample space, which we covered in Integrated Math 1 and in the Fundamental Math class. But essentially here, it's like adding two individual probabilities. You have 4 3s, you have 4 4s. So the probability of drawing a 3 is 4 out of 52. And the probability of drawing a 4 is 4 out of 52. So the probability of drawing a 3 or a 4 is 8 out of 52. And then you can reduce that by dividing by 4 to get 2 out of 13. Now, you won't always have a value for your probability. In some cases, you may end up with a situation where your probability is 0. So for instance, and I'm going to clear some space here. Let's say, also looking at that example with the deck of cards, let's say I asked you, what's the probability of drawing a heart and a diamond, for instance? So probability of drawing a heart and a diamond. So again, you're pulling one card out of the deck out of 52. It's impossible to draw a card that is both a heart and a diamond. Those are separate cards. So this probability would be 0 out of 52 or 0. So if there is no overlap, it is possible to end up with cards that don't have a probability, or that rather, more specifically, they have a probability of 0. So that is always a possibility. Now, we'll talk about in later sections what's known as either mutually exclusive events or overlapping events, but we'll get to that in later sections for Unit 10. In addition to intersection and union, we also have a couple other words we want to define in 10.1. The first of which is what's known as a subset. And of course, as always, there's a formal definition of a subset. Basically, a subset is a set of elements where every element is a member of a larger set. So for instance, let's say I put another circle in here, and let's call it S, for instance, for subset. Okay, so the symbol for that looks like an elongated C with a line underneath it. So that symbol, and again, this is in your special characters, but this represents a subset. That means every element in S is a subset of A. Now we can define this using a Venn diagram. We could define this using a list of numbers. So let's say A was, we'll keep with the same example from earlier. Let's say it was 1 through 6. Okay. So a subset would be something that is contained within that set. So for instance, let's say set B, for instance, is 1, 2, and 3. Or not B, rather, sorry, S. So if every element in S is also an element in A, we call that a subset. So that's another thing that you're asked to define and give an example of. Okay. And then lastly, we want to know what is a complement. A complement is basically the opposite of your set. So this would take a little bit more of a definition. In terms of your Venn diagram, your complements, let's say call it C, are the elements outside of your existing set. So it's neither A nor B, it's everything else. So for example, let's say I defined A, my set, as being all the elements where they are, let's say, integers. Remember, integers is notated by a capital Z. So the complement, which you can see this in different notations, but the complement is typically identified by a tilde, which is that little squiggle that you see on top of Venn. It's in the top left of your keyboard. But that's read as not A, or the complement of A. So if A is your set of integers, then A would be all the numbers, okay? All the numbers that are real, okay? Where X is not an element of the integers. So everything that's not an integer would be the complement of A. And you don't need to write that out in notation form right now because we're doing this online. But when we go back in person, we'll be spending a lot more time on being able to write set notation and what each of those symbols means. It's meant to be a shortcut, but if you want to write it out in words, I'm okay with that. We could do another example. Let's say I define set B as being the even set of numbers. Okay, then the complement, well, what are the numbers that are not even? Then the complement of B would be the odd numbers. Now, the reason this is important is because sometimes, depending on the probability event that we're looking at, sometimes it's easier to find the complement than it is to find the actual event, depending on how many elements we're looking at. It might be quicker to find the complement and then subtract 1 minus the complement to find my probability event than having to find the probability event multiple times. But we'll talk about that more in detail as we go along. If you guys don't have any questions, for me, you're good. Otherwise, please reach out during office hours. Have a good day, and I will talk to you soon. Bye.